Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about bigger is not better. I get a lot of room forms submitted each day, 10, 15 a day on the average. And I see this issue constantly, so I wanted to bring it up and let you know how much of a problem it is, so that when you see it in your room or you're thinking about it in your room size and volume selections and system selections, that you can be more aware of it. Subs in particular, the number of low frequency drivers in a room is critical. Bigger size subs, more subs, not necessarily the way to go. There's a relationship between the amount of energy that a room will hold based on its size and volume. You have to be aware of that relationship. You want more energy in the room, make sure the room size and volume can handle it, or you're going to cause a whole plethora of other issues within the room. The room is very pressure sensitive. Based on its size and volume, it can only hold so much energy at certain frequencies. Let's look at an example. The difference between a 10-inch sub and a 12-inch sub is about 2 dB more in output. So we get more output, more energy from a 12-inch over a 10-inch. What does that do to our response curve? Here's an average response curve in most small rooms. Big bump here. So, are we going to take another 2 dB of energy and apply it here? Do we want more of that? I think we want less of that. Don't forget that this is the fundamental, and we have all the harmonics that go with it. So not only are we exasperating or exaggerating our low frequency issues by adding more energy in a room that has a certain size and volume, but we're also impacting the harmonic structure, first, second, third order harmonics of the room. So you have to be very careful and match these up. Fundamentals and harmonics, very, very critical. It's not just this one frequency that you're impacting. If we're going to add energy, more energy to a problem, you're going to get problems throughout the harmonic structure of the room and frequency response also. What do we want from our low frequencies? We want definition. We want the same definition that we get with our middle and high frequencies. Well, maybe not the same with the high frequencies, but definitely the same with the middle frequencies. We want to be able to hear every note. We want every note to live and die on its own volition within the room. We don't want the room contributing to its lifespan. We don't want the room taking away from its lifespan. We want the room to let it live and die on its own volition. And how do we do that? We do that by managing the attack and decay rates. And you're not going to do that with foam, and you're not going to do that with building insulation. You'll have to have a physical structure that's designed to work with pressure, because this is a pressure-activated problem. So bigger is not necessarily better when it comes to low-frequency energy. So watch the number of subs in your room. Go for the definition. Watch the fundamental and the harmonic variances that you can get, and strive for a good attack and decay rate. In this graphic, we've broken down some cubic volumes for you and give you an idea of what subwoofers work best. So I hope this helps. Remember, bigger when it comes to subwoofers and low-frequency drivers, not necessarily better. Thank you. I hope you enjoyed today's video. If you did, give me a thumbs up so I know that it had value to you. And please, if you have any questions, leave them in the comment section, and I'll be more than happy to answer them for you. Alternatively, if there are other topics that you wish to discuss or see discussed in a video presentation, send me an email, info@acousticfields.com, and we'll get them on our list and get them done for you. I release a new video about every week, so stay tuned to our YouTube channel and keep updated on our new videos.